Hello friends, welcome back to the part 2 of application derivative maximum minima question. In the previous session, we have seen couple of very interesting questions and we have understood the steps which we need to follow to solve the problems of maximum minima. The step number 1, as discussed in the previous session also, is the most important and most difficult one, is what students think, is forming the function. So by reading the question carefully, the word problem you have to read very carefully and make sure that you form the function in a correct way. So let's begin with this particular question at present. We have to prove that height of cylinder of greatest volume inscribed in a cone is 1/3 of the cone. So basically हमको क्या प्रूव करना है कि if there is cylinder inside the cone of greatest volume, then height of the cylinder is 1/3 of the height of the cone. That's basically, if I take capital H to be the height of the cone and small h to be the height of the cylinder, we have to prove that height of the cylinder is 1/3 of the height of the cone. This is basically we want to prove. This is the first thing which you need to understand, and this is happening when the volume of the cylinder inside the cone is maximum. That is the greatest volume. This is the first basic thing, is to understand this question very nicely. Okay, so what is the formula for volume of the cylinder? Do you remember the formula for volume of the cylinder? Just recall, the formula for volume of the cylinder is pi r square h. Now there is problem. We have two variables, right? Variable r and variable h, but we can differentiate with a single variable thing, right? So the first most important thing is how we can convert either radius to height or height to radius. Now this is where the difficulty lies. Okay, since it is r square, I will not think of converting radius to height, but I'll think about converting height in terms of radius. So what we'll do here is observe ये कैसे करना है, यही सबसे important चीज है इस problem में. Now the first step, next step is the one which actually doesn't click in the exam very quickly. So what I do here is observe there are two triangles. One is triangle ABC, other is triangle ADE. Now can I say these two triangles are similar by angle test? Okay. Now what we do is, since these two triangles are similar, can I say the ratio of their height have to be in the same as ratio of their radius? So what is height of the triangle ABC? AB. ठीक है, height of the triangle ABC is AB, but if you observe A to B is nothing but A to D minus B to D. Why I am saying something like this? Because AD is the height of the cone and BD is the height of the cylinder. This is basic thing which you need to understand very nicely. So what I do further, understand that thing very nicely. Okay. So what I'm saying is, I'm saying in this triangle ABC and ADE, we have AB upon AD, that is height of this triangle have to be in the ratio of base of the triangle. Both are right angle triangle basically. But as discussed, what is AB? AB is nothing but AD minus BD. That is nothing but height of the cone minus height of the cylinder. Okay, height of the cone we have taken as capital H, height of the cylinder we have taken as small h, okay, upon height of the cone. Okay, this is equal to r here is base, which is radius of the cylinder, and capital R I have taken as the radius of the cone. Now this will help me to write h small h in terms of small r. Observe कैसे करते हैं ये. So what I'll do here is I write h upon h minus, this is r upon r, So what I'll do here is, this is 1 minus h by h equal to r by r. I want to write h in terms of r, small h in terms of small r. This is need to be understood very nicely. So I am saying 1 minus r upon r is h upon h. So capital H times 1 minus r upon r is h. Okay, this is going to be my equation number 1. So what I did here is, I wrote height of cylinder in terms of radius of the cylinder, where height of the cone and radius of the cone is a constant. Okay, this is what is challenging in the exam. Once you do up to here, now substitute this value of small h in the formula for volume of the cylinder, and then we'll follow the steps. क्या steps है? Take first order derivative, take second order derivative, then take first order derivative to be equal to 0. ठीक है? Then take this value of r, what you get in terms of h or in terms of capital R, substitute this value in double derivative. If double derivative comes out to be negative, we can claim it is maximum. Okay, so let's proceed further. Let me write what is the formula for volume of the cylinder, that is pi r square h. So what I'll do here is, keeping pi r square as it is, I'll substitute the value of h as h times 1 minus r upon r. Now what we need to do here is, we need to simplify this. Since I am going to take this as function of r, okay, let me write it in a way so that we can differentiate very easily. So keeping this in mind that this capital H is a constant, what I'll do here is, let me write pi h and multiply this r square inside. So 1 into r square will give me r square, and 1 into r will give r square into r will give me r cube upon capital R. Now what we need to do is, we need to differentiate this, right? So I got a function in terms of r. Let's take the derivative, first order derivative, keeping pi h as it is, derivative r square will be 2r, derivative r cube is 3r square. This is just first order derivative. I have take derivative one more time. So this is nothing but derivative of 2r will be 2, derivative of 3r square will be 6r upon r. Now what next? Take first order derivative to be equal to 0. So I am saying, taking f dash of r equal to 0, what we get? We get pi h 2r minus 3r square upon r, this entire thing equal to 0. I can take pi h on other side, 0 upon pi h will be 0, and pi and h are not 0, right? So we can divide that. So what we get is, we get 2r equal to 3r square upon r. Let's simplify this also a little bit. We can very easily cancel r from both sides, because radius is not equal to 0, right? So you can cancel both the sides. So this is 2 times capital R equal to 3r. So we get 2r upon 3 is r. So I got radius of cylinder in terms of radius of the cone. Now the question could have been this also, that prove that radius of the cylinder is 2/3 of the radius of the cone. Okay, but that's not what we want to prove. So what I'll do is, I'll substitute this value in double derivative and check whether it is negative or positive. So observe this. So I say, since double derivative, what is double derivative? F double dash of r हमने ढूंढा था, that was pi h 2 minus 6r upon r. So what I'll do is, I'll substitute this value of small r and we'll conclude whether it is negative or positive. Observe कैसे करेंगे. So keeping this pi h as it is, 2 minus 6, I'm substituting the value. This value here is 2 times r upon 3, everything by r. This r is getting cancelled. This will be 3 to the 6. So what we get is, we get pi h 2 minus this 2 and 2 multiply कर देते हैं, 2 minus 4 हो जाएगा. So this gives me minus 2 pi h. Can I conclude minus 2 pi h is definitely negative? Because height तो negative होगा नहीं, pi भी negative नहीं है. So 2 times pi h positive value है, a positive value multiplied by minus, will be negative. So I got double derivative to be negative. So I say therefore volume is maximum when, at present हमें क्या मिला, at present हमें मिला when r, the radius of the cylinder, is 2/3 of the radius of the cone. But what I want to prove now, I want to prove height of the cylinder is 1/3 of the height of the cone. Let's see how we can do that. Recall what is the value of h we have taken in the beginning. The value of h we have taken in the beginning is h times 1 minus r upon r. Let's substitute this value here. So I am saying this is my equation number 2. Substituting this value of r here, what we get is, we get 1 minus 2 times r by 3 upon capital R, but this r is getting cancelled. So we are left with 1 minus 2 by 3. इसको simplify करेंगे तो this will be 3 minus 2 by 3. This is nothing but 1 by 3. So what we got? We got height of the cylinder is 1/3 of the height of the cone. This is what we want to prove. Okay, again I am saying the way we have begun this question is more important. The way I have observed that in that triangle we are getting two similar triangle and comparing their height with the base, we got the value of height of the cylinder in terms of radius of the cylinder, and then we substitute that in the formula of volume of the cylinder to convert two variable thing into a single variable function, and then we differentiated, double differentiated, take first order derivative to 0, get the value of r, substitute in double derivative, negative आया तो maximum, and then we prove the last thing, that is height of the cylinder is 1/3 of the height of the cone. Not easy, but not difficult also. You have to make sure that you practice such problems and get good marks in the exam. If you are new to the channel, अगर concepts ठीक से समझ में नहीं आए होंगे आपको, तो first part में we have given the steps which we need to follow to solve problem on maximum minima. You can watch that video also and observe how easy these questions are once you follow the steps. Everybody, bye for now.